Hey guys, welcome back to my channel. Today we are going to talk about what system calls and interrupts are. System calls. It's basically a way for the application programs to talk to the operating system or specifically to the kernel when they want to request for a particular service. This is done via APIs. So the system calls are nothing but APIs. It provides an interface between a process, that is an application that is running the program, and the operating system. System calls are the only entry points into the kernel system. So yesterday we spoke about the user space and the kernel space. The application programs which are running on the user space and all the other important processes are running on the in the kernel space. So in order for the application programs to speak to the kernel, okay, they have to be context switched into the kernel space. So this is only possible via the system calls. All the programs that needs resources, they need to make the system calls. A system call is initiated by the program executing a specific instruction which triggers a switch to the kernel mode, allowing the program to request the service from the OS. The OS then handles the request, performs the necessary operation, and then returns the result back to the program. And then the program continues to do what it's supposed to do. So some of the system calls, they provide the following functions. Process control, which is to start, create, end and abort a process. It's also used to allocate and free memory. It is used for file management, like open a file, read a file, create a file, etc. It is used for communication, that is inter-process communication. It is used for device management. So all this, if the application program wants to do all of this, then it has to make system calls to the operating system, and that operating system will help in achieving all of this. Okay, so let's see an example. Okay, if in step by step we'll see how a system call works. So let's say I'm running an application program. It needs to do something special. Okay, like reading a file or maybe writing to a file. Okay, so the program makes a system call request. There is a special predefined instructions to make a request to the operating system. Like if you want to create a process, you have the fork call, you have the wait API, you have the sleep API, you have the chmods to give permissions to a particular file, chown. So like that we have many such already predefined APIs of like in Linux. Okay, so you can use those and make a system call whenever it is needed. So once that application makes a system call, the operating system will see that and it will recognize that the program needs help at this time. So it will temporarily stop executing whatever it was executing, and it will give all the control to the special part of itself called kernel. Now kernel will solve the need of the program. Okay, it will perform the operation whatever is requested by the program. Example, reading a content from a file, etc. Once that is done, the OS will give back the control to the program for further execution of the program. So this is how the system call calls the OS, and the OS will then fulfill the need of the system call and return the control back to the program. Now let's see what interrupts do. Okay, it is a signal emitted by a hardware or a software whenever a process needs immediate attention. It alerts the processor that a process requires interruption of current working process. In hardware, one of the bus lines is dedicated for this purpose. When a process makes, so we have two kinds of interrupts, software interrupts and hardware interrupts. Okay, software interrupts are basically traps and exceptions, or maybe system calls are also called as software interrupts, like open, read, write, allocate memory. They serve as a signal for OS to respond to these calls. Okay, then there are hardware interrupts. Hardware interrupts, you have hardware devices like input devices like mouse, keyboard. So all of these are connected to the interrupt request line. It's one line for all the devices. Okay, so whenever a device needs the interrupt, it will close its switch. And using the logical OR operation, you can know which device has interrupted. Okay, so once an interrupt occurs, right? Let's say I'm writing a software program to open a file, and I do my application needs to open a file, so it does a system call. So what happens is the interrupt gets sent, it's emitted, the processor gets notified, the processor will complete the execution of that instruction, and then it will check if it has any interrupts which are pending for service. If there are no interrupts which require its attention, then it will move on with the program. It will execute the next instruction in its program. But let's say it has an interrupt which needs to be serviced. So what it will do is it will store the instruction which it is pointing to. That memory address it will store in a temporary variable. Okay, once it stores it in a temporary variable, it will then load the first interrupt handlers function into the program counter. Okay, so basically what happens is an interrupt is emitted by the system call, right? So that interrupt has an interrupt number associated. Okay, now there is something called as an interrupt vector table. It's a data structure. Now that data structure has an interrupt number. So each interrupt has an interrupt number. That interrupt number also points to an interrupt vector, which stores the information of something called as interrupt service routine or interrupt handler. It is basically a program which needs to be run in order to handle that interrupt. Okay, so whenever there is a system call, like let's say open a file, there is a particular interrupt gets emitted. That interrupt will have an interrupt number. We'll look at the interrupt vector table and we'll see that the open a file has this number associated with the interrupt vector. Okay, the interrupt vector points to the it's a function pointer to the ISR, the interrupt service routine. Okay, we will load that interrupt service routine into the memory. Then the interrupt service routine will perform its instructions. It will execute all its instructions. Once all the instructions are executed, then the OS will give the control back to the process. Okay, then the processor will load the address from the temporary variable into the program counter. It will do I+1 so that the next instruction gets executed. So the program can continue further. Make sense? Now, let's say we have an hardware interrupt, right? We have mouse and we have a keyboard. Now, what happens is sometimes both of them want to access, both of them can send an interrupt. Okay, so what happens in that case? Which one do you serve first, since you have only one processor, right? So sometimes there are priorities associated with each input output device. Okay, therefore an interrupt request from a higher priority device is recognized, whereas a request from a lower priority device is not. Okay, then sometimes what happens is there are vectored interrupts as well. A device requesting an interrupt identifies itself directly by sending a special code to the processor over the bus. This enables the processor to identify the device that generated that interrupt. The other way is polling. In polling, the first device encountered with the interrupt bit set, that device is to be serviced first. Okay, appropriate ISR is called to the service, and it is easier to implement, but you know what happens is when you have many such devices, you will have to waste time in checking like which all devices has the IRQ bit set. So that's a little difficult to implement. It's easy to implement, but you know a lot of time is wasted in checking that. So this is how you know when you make a system call and interrupt is emitted, and then you know you Based on the system call, we have an interrupt vector table which we'll look up, and we'll see which interrupt was called, and we will call that particular interrupts ISR or the interrupt handler routine. Okay, once that is executed, it takes care of the interrupt. The control will be returned back to the application so it can continue execution of the program. So these are the two important concepts: system calls and interrupt service routines. Okay, interrupt handling. This is how you are able to communicate between the user space and the kernel space, what we discussed yesterday in the last video. Okay, so if you haven't watched that video, please go through the user space and the kernel space. In kernel spaces, we do privileged actions, and these are not supposed to be done by the applications. So if applications need to do privileged actions, then this is how they'll have to make system calls, and the interrupts will help in achieving those actions. Please do let me know in the comment sections if you guys have any questions. Please like, share, and subscribe. Thank you guys.